what we have here is a simulation environment using the ArduPilot software as a firmware for a flight controller. We're using Mission Planner as the ground control station software. And we're using RealFlight as the physical environment simulator. What we're going to see is a combination of the Spydar MDAR vehicle running ArduPilot in its Ardu plane configuration for quad plane, customized for MDAR. And what we're going to do is I'm going to connect to the vehicle, load a mission, and then execute the mission in full MDAR configuration. Okay. The first thing I'm going to do, I'm going to just double check the connection to the vehicle here from within Mission Planner. We specify the
mode change to stabilize,
and we specify
heading to waypoint 1.
The baud speed, etc. Okay, so it's loaded. Looks like we have some display issue here with the mission plan, so let's reload it from the vehicle. There we go. And when we go back to the main screen, that's showing the correct plan. So all we're going to do is we're going to describe a basic square loop in the sky. And to get it started, I'm going to make sure that we're in the right mode and make sure that we are ready to start here in the simulator environment. Okay, so I'll switch back and forth slightly between the screens just to show a relative position along this circuit that the plane is going to do, and then we'll come back to RealFlight to watch the action take place in real time. Okay, so I'm going back to the simulator that simulates our physical environment. I am going to be taking part of this window and move it over here so we can see it. And I am also going to be
no RC receiver.
Part of our simulator window. Move it over to the right. So hopefully we can see all of the information at the same time. Very well. There's the heads-up display. There's a simulator environment and all of the telemetry that we're receiving. So now I'm arming the vehicle, which arms it in Q stabilized mode, and I'm switching into the auto mode here on the transmitter.
Mode change to auto.
So that is the autopilot doing the takeoff and initiating the transition. We can look at the messages. Any completed transition. Transition airspeed reach 15 meters per second. And completed the transition. So we'll keep watching the telemetry. And I'm also going to have a view of the vehicle in a chase view. So I'll keep that view there in the background. And in the meantime, we can see what the vehicle is doing on the map. So we can see it's approaching waypoint number 3. So we're going to see it turn.
Heading to waypoint 4.
As the heads-up display changes, and we can see on the map what the vehicle is doing. So this would be the way to fly the actual vehicle on the field, using the ground control station to track the vehicle when it's beyond visual line of sight. We're going to be able to track the time in the air, ground speed, and all these other telemetry that we see. So according to this, in our simulation, we've traveled 1.5 kilometers. And we've used just under 1,000 milliamp hours. So here we go. We're making another turn. And we can see in the simulator that that's exactly what we're doing. Once we get close and make this turn, I'll switch back so that we can see the transition back into hover and landing. So for now, we keep tracking. We keep an eye on our altitude. We keep an eye on our airspeed, our battery usage, our current and voltage. Okay, so we're getting close. So I'll switch back to the simulator. And we're getting close to the landing point. I'm going to switch back to the fixed pilot view of the plane. And we can see in the distance, the plane is approaching the landing area.
Heading to waypoint 7.
And the autopilot began the transition to VTOL land, and it's doing the actual land. The autopilot is controlling the descent speed, and it's controlling the attitude and stability of the vehicle until it touches down on the runway.
Confirmed.
And that is the simulation of the Spydar Cav Mini vehicle. Thank you for watching that.